Hello, good afternoon, everybody. Thank you for joining the Thermos Train the Trainers program. This is the last edition after 4 years, and we are about to start in 1 minute. Thank you very much for all that are connected. You will be in silent mode now. Please, we also encourage you to put any question or any comment in the question box or in the chat box. If you have any problem hearing us or looking at us also, please let us know. If you would like, you're also encouraged to turn on your camera if you want, but you are free to contact us via the questions or chat box. Okay. Okay, so we are going to start. Thank you very much for all joining. Okay, so thank you very much. Welcome in this afternoon to the Thermos Train the Trainer program. As I said before, this is the last edition that we are developing in our project, in our Thermos project. And today is the kickoff of the program. We are going to give you some insight of how the program is going to be structured, and also to give you some news and insights about the Thermos tool. So the agenda for today, the agenda that we are going to have today, we would like to have 1 hour with you today. Hopefully we will end up on sharp. But the idea of today is to give you, of course, a welcome and introduction about Thermos and the Thermos project itself. Then you will have an introduction of the details of the Train the Trainer programs and the different requirements and the different process that you have to follow to become a Thermos trainer. Then we are going to explain to you the key features of the Thermos tool, and we are going to develop a basic Thermos tool demonstration so you can have a flavor of what the tool is and how the tool is going to help us working on designing district energy networks in our cities. At the end, we are going to have a space for questions and answers, and we would like to have this process very interactive. My name is Daniela Torres. I work for ICLEI, Local Governance for Sustainability, and we are part of the Thermos project, which is an European Horizon 2020 project that is aiming to develop a tool that you are going to know today. So let's go to the next slide. So just for you to know that the event now is being recorded. We are going to use this record to share it with other trainers, with other participants. So I hope you are happy to be recorded. If not, please write a message to us. So now I would like to introduce our presenters for today. We have Martin Holly and Tom Hinton from CSE. They work from the Center of Sustainable Energy, and they are going to share with us the key insights of the tool. Martin and Tom, especially Tom, he's the expert developing the tool, so he knows all the details, and he's going to be here for us to answer any doubt that we may have. Martin is the project coordinator. Martin will also give us an introduction of the Thermos tool. And then the other part of the team, the ICLEI team, if we go to the next slide. The ICLEI team is formed by 3 people. Probably you have already received some emails from us. As I said before, myself, we also have Alexandra Fall. You have probably know Alex is in charge of the communications and stakeholder engagement in the project of Thermos. And also we have Julian, which is also civil engineer working in the ICLEI team in charge of the technical rollout of Thermos within local governments. Julian, thank you very much for being here. Thank you very much for all of our participants to be here. We know that we have Also our Thermos partners connected today. Thank you very much for being here. So as I said before, this is the fourth edition of our Thermos Train the Trainers program. But before going to the details, I just would like to briefly mention what is Thermos. So for your information, Thermos is an Horizon 2020 project. It's a research project that started in the year 2016 and will end finalized in 2021. And it provides this project provides advanced energy system data and models in a user-friendly open source software to make heating and cooling network planning faster, more efficient, and more cost-effective for our cities across the globe. Here you can see the different partners. We are an international project working with hand-to-hand with different cities of Europe, and also with key partners from the research, academic, business sector in order to develop a tool that allows cities and city planners and thermal energy planners to work faster in designing new and sustainable district energy networks. The project, just also for you to know, the project is finalizing next year, early next year, and that's why this is the last Thermos Train the Trainers program. So you are very lucky that you will be able to learn now based on a whole years of experience of the project, and now everything is in one single tool that you will be able to use freely. So the next slide. So we are going to, in the next slide, I would just like to clarify why Thermos is for. So Thermos is a thermal energy resource modeling and optimization system. It's an open source free software designed to optimize local district energy network planning processes, support sustainable energy master planning on a city and regional level, and also to identify and select low carbon heating options in real geography. So with that, with this introduction, I would like now to give the floor to our colleague Julian Imania. So Julian, the floor is yours. Just a quick reminder, if you have any question or any doubt, please don't forget to write in the chat box that you have on the right hand. Please, thank you very much for connecting, and we know we have people connected from all over Europe and also across Europe. We have participants from Latin America. We are very happy to have you here. Welcome, and we hope you are going to enjoy the program. Thank you very much. Julian?
Thank you very much, Daniela. Hello, everybody. Good afternoon. Welcome to the Thermos training program once again. Happy to be here. And now I'm going to give you a little overview of what the training program is going to be about. So as you know, this training program is starting right now today, and it's going to last until the mid-December. And with this training program, you have the opportunity to become a Thermos expert in less than 16 hours. So I think it's a really good opportunity. It's really easy, just a bit of work. And in the end of the program, you will get a Thermos certificate. So it's really worth it. I'm going to explain you, as you can see in this table, with what the program consists about. So the first thing are three webinars. So the first webinar is the one where we are all right now, so you can check this already as done. And then we will have other two webinars. The first one, the 12th of November, where some of our Thermos partners will share their case studies, which I think it's really interesting for you. And then you also have to join the last webinar on 10th December, which will be like the closing webinar for this training program, where some of the trainers will present their case studies, and we will make the closing ceremony and giving the certificates. Apart from these webinars, we have two options for the training. You can either make some exercises or you can develop a case study. So first of all, I'm going to explain you the exercises. These are just three training exercises that you will have to make and submit, and we will correct them. And if they are correct, the 1st of December, that's the deadline for you to finish all these exercises. And after finishing this, you will automatically get the certificate. Don't worry if you miss anything today in the webinar, because these exercises have an explanatory video, each of them. So I think it will be very clear for you to make them. But of course, you could ask questions that might pop up to you in the future. And then we have the second option, that it's to develop the case study. So there's this option that instead of the exercises, you make a case study. We will assign you a tutor for that, so that they help you with your case. The deadline for this option is also the 1st of December. And those that make the case study may be presenting them in the last webinar. So that I think that would be really interesting for all of us. And that's really it. After all of this, you will get the certificate. So as you can see, it's very easy. Just for you to know, you can find some additional very interesting material in the Thermos website in the training section. Here you will find some recorded webinars, interesting for district heating, and also many scientific publications. So this is not compulsory, of course, but we really encourage you to give it a look. And I will let our colleague Alexandra tell you now how to submit your exercises. So Alex, could you explain that to us, please?
Yes, of course, happy to do so. So we try to make it as easy as possible for you, which means you will receive one email from us after this webinar, where we will outline you where you can submit your exercises. So for the exercises, you will receive an automatic invitation to Google Forms. Don't worry if you don't receive it because it's ending up in your spam. We will also provide you with the link. And if for some reason you cannot use Google Forms, we uploaded the exercise as a Word document on the website. Link will be included, so we think there should be no problem for you to find it. For all of those who are interested in doing a case study, we prepared a small form similar to the one that you signed up for to the program. It will take you less than 1 minute. It's just for us to get your contact details and 1 or 2 explanations of what interest you have in the case study, so we can make sure to find the right tutor for you. So, but again, everything will be explained in the email, so just watch out for our follow-up communication, and I think it will run smoothly then. So, looking forward to getting in touch.
Thank you, Alex. Great. Then I think it's clear now. You will, of course, receive this email, and just keep in mind that the final deadline will be the 1st of December. It seems to be far away, but you know that time flies, so keep it in mind. So now I will like to give the floor to our presenter, Martin, and he will give you a best overview of the Thermos tool. So please, Martin, when you want, you can start.
Great. Okay. Thanks, Julian. And afternoon to everyone. So this is just going to be a very brief overview of Thermos and its key features, really. And I thought it would be useful to start by looking at what Thermos is typically used for. So if we go to the first slide there, you can see the typical stages of the sort of the heat network planning process, and going from mapping and master planning through to construction and operation. And we think that Thermos is predominantly suited to that first step, mapping and master planning, but it actually does overlap that second process as well, techno-economic feasibility. But it doesn't go into the detailed elements of that, where you might be considering the more detailed engineering side of things, such as hydraulics of the network and the detailed costings. But it does help to focus on which areas or building clusters might have the most potential in the area that you're considering. It might be a city or an area of that city. So you can focus on which bits then might be worthy of a further full feasibility study and the investment that entails. There's 4 main use cases of Thermos, you can see there as well. So this is about extending existing networks, or it could be about finding the best route for a network where you have a known heat supply and you have the known demand, you have a known set of end users. But it's also about where there's a known heat source, and you might have sufficient local demand to create the network for that heat source. And finally, deciding between a networked and a non-networked solution. So, for example, where an optimized solution may involve reducing the energy demand of a particular building by installing insulation, and then using individual heating systems within that building, i.e. that building's not connected to the network. So that's what we mean by non-network solutions, which Thermos considers as well within the buildings that are being analysed. Okay, on to the next slide, please, Julian. So who can actually use it? So actually anyone can use it. It is a web-based, open source, freely accessible resource, and it's been designed mainly with local authorities in mind, but other stakeholders as well who are involved in the district energy system planning process. There's quite a comprehensive online help that you can access via the tool, with a quick start guide as well, and that's constantly being updated as the tool is being developed. And in terms of skill levels, you know, what kind of skill level do you need to engage with Thermos and use it? We think that there's a basic understanding needed, basic level of understanding needed of energy systems and the typical units that you might come across when you're looking at energy issues. And there's also an optional facility within Thermos to upload your own local data, which has benefits of improving accuracy. And so in this case, it helps to know, have some experience of GIS systems, or know someone or have a colleague, someone who can look at that and upload that data. That is an optional thing, but it's useful to have that on hand if needs be. Okay, so what I'll go through now is just looking at basically there's three key features of Thermos. There's three main functionalities within the tool: mapping heat demand, optimizing a network, and optimizing heat supply. So this first one, mapping heat demand, it uses the tool uses quite a sophisticated model, which is based on the building shape and local heating degree days, which is a measure of how much heating is needed in a building for a particular location. And it's something that's you can enter that as a user as you're going through the input stage of the tool, as Julian will shortly demonstrate. And by default, when a map is imported, as you go through the initial stages of using the tool, the model will use two-dimensional building polygons from OpenStreetMap for the location that's been selected by the user, and it uses those then to estimate energy demand. But if there's LiDAR data available, which is essentially about building height, then it will then enable the tool to use a three-dimensional model which considers building shape and volume, which is obviously more accurate. The problem there is that LiDAR coverage is variable. So coverage and availability is variable across Europe. So when you start to use Thermos, it's certainly worth seeing what the situation is in your area with regards to availability of LiDAR. It may be that you have your own local data regarding energy demands and building height, that kind of thing, which will help. But if not, then you could see if LiDAR exists for the location that you're looking at. Cooling demand estimation is a bit more basic because we struggled to find a really good, robust model for that. And it's done using fairly straightforward, very simple floor area benchmarks for cooling. And as I mentioned, yeah, you can also upload your local data So this might typically be additional building polygons that might be missing from the OpenStreetMap dataset, which is common. That's another thing that varies from area to area, how complete OpenStreetMap is. Or you could actually upload energy demand data in the form of benchmarks or actual known demands, which is obviously the most preferable option if you have that data. Okay, the second feature is about optimizing a network layout. So this so it optimizes a network if indeed it's possible to do that for the scenario that's been developed by the user. There's two user set objectives here, which either maximize the net present value NPV for the network or for the whole system. So for the first one, the optimizer chooses which demands to connect to the network so as to maximize the net present value for the network operator. So essentially, it's like the sum of the revenues from the demands minus the sum of the costs for the network. The difference there with the second one, which considers the whole system, is that the optimizer chooses how to supply heat to the buildings in the problem at minimum overall cost. And it can also do this by reducing demand by assuming insulation is installed in certain buildings. And in that case, revenues and tariffs aren't actually involved in the calculation because it's a sort of different objective that you're after there. The optimizer iterates the calculation when it's looking at the network by considering the location of the heat source, and there might be more than one. It's looking at which demands to connect to the network, which again, Julian will demonstrate how to select the options there for the optimizer to use, and also looking at the routes for the heat distribution pipes, so for the heat mains. And cooling is treated in a very similar way. So the maths behind that is very, very similar to just using heating, but obviously there's some differences around the demands themselves and flow and return temperatures, that kind of thing. And the third key operation really of Thermos is about heat supply optimization. So this is looking at the supply side of things, and it's considering satisfying a given demand at minimum cost. So when you're optimizing a network, as I was just talking about, you can just assume some key parameters for the supply in that case. So we're talking about plant capacity and cost to meet peak and annual demands and the cost of heat to do that. But you can then separately optimize the heat supply. And this is a more detailed process and takes into account hourly, weekly demand profiles of the buildings concerned. It also looks at technology types and costs, and also considers storage and combined heat and power. So if you have electrical generation as well as part of your potential solution, then it can consider that. And the idea is then to compare the cost figures that the supply optimizer has come out with what was previously assumed for the network optimization. That's the general idea. Ideally, both optimizations for the network and supply would be done simultaneously in the model, but we found that to be very complicated, very complex, and so we've kept that separate in this case, in the case of Thermos. So those are the three key operations that Thermos is about. That's what Thermos does. You might be asking yourself now, what's the main benefit of using Thermos? So, I mean, Thermos has been running for a number of years now, and so we've been asked this question quite a lot, and you know, it's changed a little bit as we've gone through the whole development process, because as is Thermos itself is evolved. But we've learned a lot about what users would like, and what elements of Thermos really do offer the most benefit. And one thing that we found is that by working with a range of local authorities as part of the project, we worked with pilot cities and what we call replication cities. We're ensuring that the user needs are met and that it's fit for purpose. So we've been developing a tool alongside officers within those local authorities to ensure that's the case. And it's also being validated in this last stage of the project with industry experts to ensure that outputs are robust and reliable. We found that to be very important to gain the confidence and the trust from users. And secondly, it's generally very fast compared to conventional methods. So, I mean, typically network planning needs quite a lot of iteration to look at different options. And Thermos allows for this. It's very quick and easy to rerun analysis, for example, to look at sensitivities of different scenarios. And this all makes it very cost effective. And again, comparing with the conventional ways of doing things, for example, when a local authority might be repeatedly asking consultants to consider multiple scenarios. So that is a key benefit of Thermos. So it's very efficient, very quick to be able to tweak things, change things, and rerun the analysis to just look at different options, different scenarios. So overall, the overall aim is to encourage, as I say, fit for purpose, cost-effective systems that are in the right location. And we all know, the benefits of heat networks, where it's a way of future-proofing against future carbon emission reduction targets, because it's much easier to upgrade a single energy plant rather than a whole load of individual systems. So yeah, that's the key benefits of Thermos in my opinion. And just to finish up, just because we are coming towards the end of Thermos now, as Daniela was saying, it started in October 2016. We've been lucky enough to have 2 extensions to the project, and it's now due to finish in March, the end of March next year. And that phase, as I said, this final phase, the focus is on validation of the models, and enhancing some of the user interface elements as well. And in addition, we're running this Pathway D trainer, final trainer program. So concurrently with that as well, we're now at the stage of developing a Thermos business plan and also a separate sustainable adoption roadmap. So this is about looking strategically about how we will take Thermos forward beyond the end of the project, and in particular looking at arrangements for maintaining the availability of Thermos beyond the project end. So yeah, that's what we're focusing on at the moment. So yeah, that's just a very quick run through an overview of what Thermos really does and where we're going with it. So hopefully that gives you a flavour of the tool. So I'll hand back now to Julian, who is going to give you a very quick demo. This is the more interesting bit of running through Thermos.
Thank you very much, Martin, for explaining the Thermos tool so well. I think it's very interesting to get this overview of what it's about. And just before we make this live demonstration to see a bit in practice the most basic things of what Martin explained, I think there are a couple of questions. Daniela, can you tell us which questions there are?
Yes, thank you very much, Martin and Julen. Yes, we have a couple of questions. We have tried to answer them during the questions moment, but I have 2 questions now that I will share with Martin, Tom, and Yulen. If we can answer this, is that if we can individually adapt the tariffs and cost of pipes and building works, or from which country is the data, as there will be significant difference in labor costs across Europe. Can we clarify this, Martin? I think that as of my understanding, this can be adjusted by each of the Thermos users, but you can clarify. I don't know
Yeah.
if Martin?
So this is specifically about costs and pipe costs. That's evolved quite a lot as we've developed the tool, but it's down to the user to confirm that their own costs for piping, but there's sort of defaults within the tool for certain parameters, and we're hoping to explain those and signpost the user to the evidence behind those, or for further information on how we arrived at those. You know, they're just suggestions, recommendations where the user may not have access to that information, or whether they haven't got to that stage yet. But in terms of cost, that I mean, there's the currency that's used within the tool is a sort of generic currency. So you have to look at that and then bear that in mind when you're looking at the costs for your own country. But yeah, pipes is a difficult one, and it does vary quite a lot from country to country. So you know, there is some information in Thermos about the figures that are in there at the moment, and we're planning to expand that with more detail over the next month or two to help the user arrive at more robust costs.
Thank you, Martin, for your answer. We have another question regarding which technologies are included on the supply side of the Thermos model in the software. Can you confirm this, or probably Tom? Martin?
So, well, yeah, it's up to, I mean, the supply technologies are basically defined by a certain set of parameters around their cost mainly. And so it's up to the user to then, you can type in what type of energy plant you're looking at, whether that's, you know, it could be a heat pump, it could be CHP, or it could be heat only. But then the thing that the tool actually uses, the thing that specifies and defines it for the tool, is the set of parameters you put in for that technology. So it's more about the numbers relating to that technology rather than the actual technology itself, if you know what I mean. I think that's, I mean, I don't know if Tom wants to add anything there.
Yeah.
If Tom's with us, I think, but I'm not sure if he can.
I will. Yes, Tom, we are trying to make him a panelist, but now we can, Tom, we can hear you.
Can you?
Oh yeah, we can hear you now, Tom.
Yes.
Oh, okay, great. Well,
Thanks,
the video
Tom.
doesn't seem to work for me, but there we go. Yes, yeah, what Martin said is correct. I suppose there are 2 bits. There's the network modeling bit and the kind of separate supply operations modeling bit. And for the network modeling bit, the heat sources or the energy center is sort of a black box which just produces heat at a certain price, or with a few different prices. You know, a unit rate and a cost for installed capacity and so on. And then in the supply model, there's a bit more detail than that. But as Martin says, essentially, the technology is represented solely in terms of what it costs to run. So yeah, that's the main thing.
Okay, thank you, Tom. We have another question. And I think with this, we close now the questions of this moment of the workshop. We will have to continue on the seminar. But we have one that says that, do you have flexibility of return temperature as well on Thermos? If existing heat network is high temperature, what would be needed to make it low temperature?
So, I mean, there are flow and return temperature controls, and those essentially affect the size of pipe that the model will believe it needs in order to deliver a certain amount of heat, and they will also affect the heat losses from pipes. So I mean, you can fiddle with those two things, and you'll get different costs for the network part. And I suppose on the supply side, if you're doing high temperature heat versus low temperature heat, that should affect your cost of supply in some way, but that's kind of down to you to think about that. Like Martin was saying, you just put in numbers that you believe. I didn't understand exactly the sort of second part of the question about having an existing high temperature network and answering a question about converting it to low temperature. I don't fully understand what the question is.
I will probably I also didn't read it well, but I'm going to send it you on writing, Tom. Okay, so we can prepare a little more the answer or do any clarification with Shivali Mathur that did the question, okay? But in the meantime, we have to continue. So now I think that we are all eager and wanting to see the Thermos in real time. So now I would like to give the floor to Julen that is going to do it a super introduction on the Thermos tool to inspire you and to inspire you to take now hands-on and go directly to the tool from your computer. So Julen, go ahead, the floor is yours, and we are going to sort any other question while Julen is presenting. Thank you very much.
Thank you, Daniela. Exactly, just I'm going to make now just a little demonstration for you to familiarize with the tool, to see how to access it and the basic features of it, just so that you start getting to know it a bit, so that you don't start from zero after this webinar. So we are going to make a super easy demonstration of the Thermos tool in the city of Bristol in the United Kingdom. We imagine we have a problem in this city, which consists of connecting 5 restaurants in this area around the Queen's Square. And we have one supply building. Imagine it's this building here, which has some waste heat that can be used for district heating. So we want to optimize that solution with Thermos and see which will be the best network to use here. So for that, I'm going to show you how to go to the tool. Okay, so this is the Thermos website. Probably most of you have already accessed it and know about it. So it's just thermosproject.eu. Here in the website, you can go to the Thermos tool section. You click here in Thermos tool. And now where it says where to access it, you click where it says here, and you directly go to the tool. I am already logged in. As you can see up here, it says welcome, Yulenimana, because I put my credentials. But if you don't have an account in the tool, of course, you can register just with your email and a password. And then in this first screen, all your projects will appear. So in this case, we will click here in new project. We will give our project a name. So in this case, we can put demo webinar 1. Oops, webinar. And we click in create project. So what's the first thing in a project? Of course, the map, the background map of Bristol in this case, where we want to work for creating our network. So we click in map. We have to give a name to the map. So we put Bristol. We click in next. And we have here these OpenStreetMaps where we can find Bristol, or if we have some GIS files, we can click there, but it's not the case now. The tool as default appears in London, but we can search here for whichever city we want. In this case, we type here Bristol. And here we have, you see, Bristol, England. So we appear in Bristol, zooming a bit with our mouse. We can go for the target area, which it's Queen Square in this case. Selecting draw a rectangle, we can select the area like this. And once we have our area for the project, we click in next. This option shows the heating degree days. We are going to leave it default here, but of course you can change this number if you know it for your own project. And we click here in create a map. It will take just a few seconds to create it. It says 80%. It's really fast, don't worry. Yeah, here it is. So now in our map, we can create a heat network or a cold network, as Martin already said. Both are very similar, so no more complications in one or the other, but in this time we are going to create a heat network, as we said. Okay, so as you can see, we are here in Bristol. All these gray polygons are the buildings with the tool models. And all these white lines are the possible paths where the pipes of our network could be installed. So what can we do here? First of all, how can we see the energy demand of a specific building? For example, this building here. We click on the building. We can see it's a building, it's a commercial building. And down here, we can see heat demand. We can see that its heat demand is 358 with 53 megawatts hour per year. We also can see the heat peak here in this number here. And we can also select a pipe, for example, well, a path, sorry. And it will tell us the length and the base cost of installing a pipe there. But imagine as we said, we don't want any random building here. We already said that we are looking for specifically 5 restaurants that are around this square and we want to connect them to a heating network. So how can we do that? First of all, you can see up here where it says draw a polygon or draw a rectangle. We are going to select draw a polygon and we are going to select our area of interest, which will be this one. You can see we're drawing this around the square, close it, and then everything inside our polygon will be selected. In this list in the right, we have all the elements selected. We have paths and buildings. First of all, we are going to start with the buildings. So by clicking in the building word, we will stay only with the buildings. We can look here for the restaurants, and here we can see 5 restaurants. So clicking in them, we are going to have selected only the restaurants. If you cannot see very well the background here, we can select maps, and maybe it's clearer. The dark areas are the selected restaurants, okay? And as we want them to be in the network, we can press the letter C in our computer. Well, it should, yeah. By pressing the letter C, you see it changes the color. Gray is forbidden, blue is optional, so it's optional that these buildings are in the network, just if they give some revenue. But in our case, we want them to be compulsorily in the network, so we press C again, and you see they are required. The next step is to have a supply building, of course. We said that we know this specific building has some excess heat that we can use for district heating. So we select the building, it's a commercial building, and by pressing the letter S this time in the laptop, S of supply, this panel appears where we can change the basic characteristics of the supply building. So we are going to put here a maximum capacity, a supply cost for the building. So it will be, for example, 3 cents per kilowatt hour. Imagine this could be whichever currency you imagine. Then we could put a capacity cost of 300 euros per kilowatt and a CO2 emission factor of 300 grams per kilowatt hour. So now we click here in OK. Again, by pressing the letter C, we put it as required in our network. And once we have the supply and the demand buildings, what do we need? Well, the pipes that connect all these buildings, right? So as we don't know which are the best paths for that, we are going to select all the area around our buildings, and we will let the model to select the best way for our network. So we are going to make, again, this polygon around the buildings, just like this. You see, everything is selected again, but this time we are only selecting the paths. So you can see I'm pressing the letter C. We are going to leave them optional, not required this time because they are optional. We want the model to select just the best paths for the network. So once we have this, we give a title to our project. We can put just demo here. And we can directly go here in this optimize word up right. We click there. We optimize the network. You might remember Martin said you can also optimize the supply, but you will learn that later with the exercises. We will optimize now the network. It will take a few seconds, but it's really fast compared to the work it takes a project like this in real life without the tool. So it's ready now. We click here in solution, and you can see these orange things are the selected buildings. These lines are the paths that the model has selected for our networks. So the model decided that the best way is this one. Also this one. It's just that the pipe sizes, the bigger they are, the thicker they appear in the screen. And well, this is just, it's very pretty to see it here, but if we want the data, we can click in this circle here. We go to solution summary, and here we can see the capital cost of the network, the operating cost, the operating revenue here. Overall, this network loses money. And then we can see here in network the pipe work use, so the size of the pipe work, the length of each of them, the cost, the losses. You can see many details here. Also the emissions, for example. So as we said, the CO2 emission factor in the supply, if you remember, we will see here now the CO2 emissions of the network. And well, here in this list, we have many other options, like the tariffs, for example. We can add another tariff because we use the default one. Maybe we know the tariffs for the heat demand of a city, and it would be much more precise. We can change here the pipe cost, insulation, etc. You will, of course, learn that with the exercises, but this was just a basic demonstration so that you can get an overview of the tool. Please ask any questions you might have, but of course, don't worry if you missed anything, because when you do the exercises of the training, you will have some explanatory videos, and it's all super clear there, of course. So we're back here. I don't know if there are any questions, Daniela, or is it all clear with this?
No, we have questions, Julian. Sorry for that. We have one question regarding that. In order to enter the costs in euros, dollar, etc., is it possible to change the currency or select the currency or include cents, or how detailed is this issue of the currency in the tool?
So as you saw, the mute yourself, Daniela.
Sorry.
As you saw, the tool didn't have any specific currency there, not euros or pounds or dollars. So you can enter the values in whichever currency, and then the tool will give back in the same. I mean, doesn't specify the currency. It's just you can imagine whichever you are using. If you put the value in euros, well, the tool of course will give back the costs in euros.
Perfect. Thank you very much, Julian. So we have another questions regarding that. Is it possible to integrate demand data from buildings that do not yet exist as it is a new part of town? If yes, will the tool consider the current energy regulation in place of each country? I don't know, probably Tom can hand out this question. Tom? So just let me unmute Tom. Tom, are you there?
Yeah, I'm here. Can you hear me?
Yes?
Okay. So yeah, new buildings. I guess if you have a small number of new buildings, there is a button next to the map that will let you sort of just draw a few new places on the map, and then you can type in what your estimate is for heat demand. I don't know if you're talking to us, Daniela. I can see you talking, but I can't hear you. If you have a lot of new buildings, which you want to include in a map, you probably need to do a bit of GIS work yourself. So you might have drawings for where the buildings are going to be. In which case, I don't know, you could get hold of the GIS data for the area as it is, and then you could add in your new buildings and mark them in some way as being new, and then load them in through the sort of GIS input kind of page, and then they'd just be in there like other buildings. Yes, the new thing, it's the button on the left,
It's here,
at the
right?
bottom. That
You
one,
can
yeah.
here
We'll let you
draw
draw just a single new thing. It just puts in a little circle because the shape doesn't really matter if you've got to type in all the stuff anyway. So yeah, you can make a new building and connect it up if you want to, but it's a bit tedious to do lots of buildings that way.
Yeah, and regarding the energy regulation part, Ralph Ripken, which is the person that is asking this, says that it stands in kilowatt hour square meters per year. So it would be it makes sense. This can be included in the software, no?
So at the moment, the software doesn't know anything about that. I mean, if you had a bunch of buildings that you were going to build, and you know their floor area, and yeah, you've got a benchmark that's regulated, I would say get your GIS program and make those shapes have the demand on them, and then load them into Thermos. So it doesn't really know about the regulatory context, but you can certainly put in a building that has a specific demand, and it doesn't really mind if that's a building that you've invented and given a demand by some calculation associated with a benchmark or what. Does that help?
Yes, I think so. I don't know, Ralph, if you have any other question, I can give you the floor, Ralph, if you want. No, he said super thanks, so no need to make him speak. Next time I will ask Ralph to intervene directly. Thank you, Ralph, for your question. So in terms of also, we have another question from Christopher Jones saying that if it is possible to add buildings that are proposed for development. I think that this question is already answered. And regarding, we have some specific questions regarding can you show how you mark hitting points in the map? And sometimes the paths are unconnected, how we can fix that? Can you clarify this, Julian?
With hitting points, you mean this, the heat map?
Yeah, I think so. Peteris, please, you can intervene if you want.
Here there are some options. So you can select to see the heat map, like with the heat, let's say, hotspots. You can see labels like river, street names,
Yeah,
and
he means,
candidates.
yeah. Peteris means the supply points.
Oh, supply points. Well, the supply points, you have to select them. So as we selected this building to be a supply, you can select this one to be a supply too, but you have to convert the buildings in supplies. You mean that? You have to know which building will be the supply, select it, press the letter S in the computer like this, and then set here the supply characteristics of the buildings.
Okay, thank you very much, Julian. We have another question regarding that if the software use the latest updates of OpenStreetMaps. So if a new building has been added, should it automatically enter Thermos, or there is a delay of OpenStreetMaps updates transferring to Thermos? I don't know, Tom, can you clarify this, the relationship with OpenStreetMaps and the versions?
I can answer that if you like. So when you make a map, the application speaks to OpenStreetMap directly. So at that point, anything that's in the OpenStreetMap database should appear. After that point, the map is not connected with OpenStreetMap. It's a copy of the data that was seen at the time when you press the button. So adding a new building to OpenStreetMap will not make that building appear in your map on Thermos. On the other hand, adding a building on OpenStreetMap and then making a new map in Thermos will see the change.
Okay, perfect. Thank you very much, Tom. We have another question, Julian, for you. Can you please show how you can change the tariffs in the software? The tariff.
Okay, so you will see this in one of the exercises in the videos, but we can quickly show it here in this the list that appears here in the left. By clicking the Thermos icon, you can go to tariffs. So this is the default tariff applied to all buildings, but we can add here a new one. So it's going to be called P2, for example. We can see the euros per year. Imagine we want to put 40 this time. The cents per kilowatt hours that will be charged. Instead of 5, we can put 6. And the euros per kilowatt pound year. I don't know how to read that, but imagine, well, we can leave this 0 or 1, for example. So once we have set up our second tariff, we can go back to map view. Imagine we want to apply this to all the buildings in this area, for example. We don't have to go buildings one by one. We can directly select all of this. Click here in buildings, so we stay only with the buildings. And Let me see. Where was it? Tariff. Oh, here in tariffs, we have standard. We can change this. Martin, could you remind me how to change it here? Just a second.
Press the E key.
Oh, the E. That was the.
It should
Okay.
bring up the little edity thing.
Okay.
And
This.
then,
Yeah. Into tariffs.
And then if you say edit tariffs by none, that'll just edit everyone at once.
Okay.
Or by category.
Exactly. Thank you. I forgot it. So now we can select the T2 tariff to be applied to all the 211 buildings that we have selected. Or instead of that, as you saw here, you could go one by one if you want to choose which ones will have one tariff or the other. So clicking in OK, it will be updated. Once you change these things, you could, of course, optimize again the problem, and then a new solution would appear with another solution summary. Playing with that, you could see the revenue of the network. It could change. So it gives a lot of freedom of change there.
Perfect. Thank you very much, Julian. But as you said, everybody can see these details in the videos that are part of the Thermos training. So we encourage you to see, of course, the videos in order to be familiarized more with the tool. We have 2 more questions, and the time is over, so I will be very, very fast. So Tom, we have one question regarding it's that one of the participants has troubled to import data from Esri software. Does the Esri file has to be set up in a specific way? Also in the geographic systems, so you have an example. Thanks. And the other question is, Tom, if I assume the buildings category is taken from OpenStreetMaps, in Thermos, can I change the heat demand benchmarking applied to a category?
So
I sent you the questions also in the chat.
The first question about
the Esri software.
Esri, yeah, that's probably not easy to answer, because whatever it is that you're having trouble with, I can't sort of guess. I mean, I can say that it should read shape files, which are the what Esri normally produces. It's important for the shape file to have, I guess, a shape, a polygon or possibly multi-polygon type geometry column, and you need to upload the shapefile and the sort of auxiliary other files. So like there's an SHP bit and a DBF bit, I think, and a PRJ bit. It doesn't matter what coordinate reference system it's in, so long as it's in a coordinate reference system. But the best thing to do there is probably to contact us at CSE and just provide us with the shape files, because it'll be a lot easier to figure out what's wrong just by having a look at them and going, oh, you're missing this or whatever it is. Or it might be a fault in the software, in which case it would be useful to see the files. So either way, I think probably that's best to send us the files. Whether we've got any example files, we don't. But I mean, I guess we could think about trying to make some. But there's nothing really particularly special about them. It should just be anything with a shape in it, and that's in a coordinate reference system that has an associated projection file. So yeah, that's probably the best thing to do with that. And then the other question was about benchmarks. So Thermos doesn't use benchmarks at all, really. It uses a different model, which is documented in the help. But the demand estimates are sort of designed to work in situations where you don't know the end use of the build, where you know very little about the building. So so you might not know the end use. Ideally, it should work when all you really have is the shape and size. So I think if you want to supply your own benchmarks, there is some facility for doing that, but you probably need to go the GIS route rather than using OpenStreetMap. So if you're uploading your own shapes, you can put a benchmark column on them, or you can upload a separate table of benchmarks and tell it to use that as benchmarks. Or you could just do the floor area times benchmark calculation yourself and just tell Thermos this column has the heat demand in it. Yeah, so if you want to do, I think if you've got sort of opinions about the heat demand in your buildings, which you think are good opinions, the best thing to do is to prepare your own GIS file that has those heat demands and tell Thermos to use them. The built-in heat demand model is sort of there for situations where you don't already have a good opinion of your own, if that makes sense.
Yes, Tom, thank you very much. I think makes sense. And also, we can open this issue to all of the Thermos trainers. If you have any particular concern about the different files that you'll be uploading into Thermos, any GIS file, we also have another question on this. Please send us an email with this, and our team, Tom and Julian and the technical team, will be able to support you in order to make it happen. Okay, thank you very much, Tom. There's another question that I think is relevant for all of the participants from regarding the carbon part, okay, the emissions accounting part. So Joanna Skog mentions that how do you define the heat supply source in terms of emissions accounting? Can you clarify this? How we introduce the carbon component in Thermos, Tom, please?
Yeah, so the model for that's very simple. It's just a factor. You saw it earlier in the demonstration in the supply sort of window that comes up when you, yeah, there we go. So you can just say the factors, and they're just in terms of the output that the plant is producing. So the model of plant in here is very simple in this bit. And there's no real facility in there for anything like emissions factors changing over time or anything like that. It really is just, well, you know, if you make so many kilowatt hours a year of heat, you make so much CO2 a year. And, you know, you can fiddle with that and see what it does. But that's about the size of it.
Perfect, Tom. Thank you very much. I think that with that, we have covered most of the questions. If I miss any question, I will come to you. We will come to you by mail. But now we have to close because we are 7 minutes ahead of time. So I just want to give you the last notes for the Thermos training program, because we are going to leave in a while. So, of course, now we invite you to explore the tool, to get involved directly with the tool. Please try it, register, use the tool. Of course, we also invite you to watch the demonstration video, and of course, all the information of the Train the Trainers program is in the web page. The next slide, the next one, please, Julian. So just some of the next steps, because remember that we are going to have a new webinar in the following days. So can you go for the next slide? So before going to the next slide, to finalize, just to let you know that there is a very interesting event on district heating and cooling, which is another project that we work here in ICLE, which is called Keep Warm. So this is a very interesting event on keeping our cities sustainably warm, inspiring the efficient renewal of district heating for the just transitions. Here in Europe, we will have high-level speakers from the European Commission to find the relationship between the Green Deal with the district heating and cooling processes. So please join us. You are very more welcome to come. We will send you the link to participate and register to this online webinar. So the webinar is in the same day of our next webinar. So we will go to the next slide. So please be prepared, and you have now 2 weeks to explore Thermos. We also invite you to think about if you would like to develop a case study or develop the exercise. That is something that is very important for us to know. We will communicate with you in order to ask you specifically which option have you selected. And of course, see you in 2 weeks, Thursday, November the 12th. So you can be in the morning in the Keep Warm event, and in the afternoon you can join again to our Thermos second webinar. In this webinar, we are going to have practical case studies of different users using Thermos. We will have an example from a city authority. We will have an example from a utility also, and other examples to share with you also from a consultancy firm. So please be aware that we are going to continue doing this practical part of Thermos Train the Trainers program. And then the third thing is that please stay at home now that we are going to be at home more time. So please take the opportunity to explore Thermos, write us for anything that you want, and always please stay healthy. So see you in 2 weeks. Thank you very much to our presenters, our trainers, our participants, and see you in 2 weeks. And here are some examples of our trainers from the last program. They were very happy of being part of Thermos. So please, you will not regret of having this training in your hands, and also to accelerate energy transition in our cities. Thank you very much, and see you in 2 weeks. Bye-bye.
Thank you.
Thank
Bye-bye.
you very much.
Thank you. Bye-bye.
Thank you, Martin. Thank you, Daniela.
Thank you, Julian.
Thank you,
Thank you,
Alex.
Tom. Bye-bye.
Bye, everybody.